Hey guys, my name is Arun Tyagi, and today we are going to discuss design of proximity service. So we already discussed about Google Maps, where we basically design for how we are going to find a route between a given source, which is latitude and longitude, and a destination, another latitude and longitude. But today we are going to discuss one part where if you basically somebody gave a latitude and longitude, which means their current location, then we need to find some places within a given radius of that. And by places it can be like if user wants to search a restaurant within 10 kilometers, or some other shopping mall or some other things, right? So that will be a proximity service. Now let's just cover functional requirement and non-functional requirements first. So, so in functional requirement, first we are having that basically find all nearby places, and in that we are basically assuming that you should be able to find nearby places with where you can say that the inputs, like within what radius you want to search, and what things you want to search, all those things are going to be variable. So sometimes you want to search within 5 kilometers, sometimes you want to extend the circle and you want to expand the circle and you want to search within 10 kilometers and all of that. Then an admin, or you can say the people who own the service, they should be able to add their places into the system, right? So admin will have that service. Then you will have end user who is consuming the service. They should be able to view the info about the place, so list of places within that given input, and also the details of that place. So that will also be there. Then non-functional wise, basically it have to be low latency. So when you are looking for something, it should not be like the response is coming in a very long period, because that is going to be the main key of this design, that how you will search something very fast, because latitude and longitude is a very long list. Then availability have to be high. By that we mean, even if some of the services are, you can say, some of the servers are down, some of the databases instances are down. If there is you can say in some area there is some network outage, then also your system should work as it is. By that we mean you should always have failover plans. And then high scalability. By high scalability we mean is there should not be any choke points. So if there are so many requests when user is trying to view, maybe in a Friday evening, at that time it should not be like your uh, load balancer or ingress controller is not able to handle that much, right? You should always have or you can say your computation server, which is hitting your databases, that server should be able to take that many requests. That means your design should be scalable by that sense. So if on Thursday afternoon you have 200 servers, and if Friday afternoon 200 servers will not be able to handle that many requests, then system should be able to auto scale, right? Your design should work in that sense. Now, like we said, that low latency is going to be the real challenge here. That is why is that? So basically, the problem we have to focus on is, location is basically nothing but latitude and longitude. If latitude and longitude are two columns into your database, then what you cannot do is you cannot use something like indexing on those columns, because even if you index on latitude, and when you are searching for one given latitude and longitude, for one latitude in that range there will be so many rows for longitude. So again, you have to search for, all the rows to get your real results. So that is why indexing is not helping here. That is why basically having a simple table in SQL is not going to help us here. So we have to think of that when we are designing it. All right. So before we jump on to, how we are going to optimize it for the latency, let's just establish a very, very high level design, that what are going to be the, major components in it. So it is going to be a very straightforward thing, where the admin, or you can say the guy who is going to add their places, for example, a restaurant, where it is located and all the details of the restaurant. For all of them, we will have, let's call it a data entry service, where you are, sending things like uh, latitude, and then comma longitude, comma, name, title, description, tags, blah blah blah. So via API you will do that. It will set into the database. That's it. Now for end user who is requesting for, maybe he wants to throw a query like that, right now I am at location this, which is obviously defined by your longitude comma latitude, right? Then what I want is within say distance 10 kilometers or 5 kilometers. Let's just say that this is going to be variable, whichever user wants to send. Then I want restaurants, right? Or like that. So this kind of query this user will send. Then you will have a service called location finder service. Right now we are not talking about how it will, but just think of that service is available. Then if we have database, data there, this service will basically just run the query onto the database, get the results, do, sorting on it, and remove some parts and all those things, and simply return that to the user. And here I am showing two load balancer. This is symbolic to show that, we will have a global load balancer, and then we will have your in front of service you will have regional load balancer. So think of, if this is an AKS cluster, then you need an ingress controller, so that regional load balancer will work as a, ingress controller for all your pods in AKS. Now we will go in deep, and let's just discuss how we are going to find in very low latency, um, how we are going to find locations in a given circle. So now there are actually many defined ways to do it. So let's just discuss all the techniques one by one, and let's just compare which one is better than other, and why, people are using some specific service for this kind of requirement. So now very straightforward thing going to be, if you have to do it, let's suppose uh, you have data sitting into your database like this. Think of it as a SQL database. You have ID of location, then you have location itself, means location of the place, which is will be defined like in latitude and longitude. Then you will have other data like name, title, tags, and blah blah blah, all those things. So from this table, if you have a query that from a given location, you can say that my current location is this center of this circle. Give me all the restaurant with which are inside this circle, right? So if you have this, then what you can do is you can simply run a SQL query like this, that, give me all the places from this table where my latitude is between current latitude and whatever radius, say 10 kilometers, and plus. So same for the longitude. So this is a very straightforward query. Will this work? Yes. But what is the issue with it is that when this table will grow, the you can say the performance of this query is going to be very bad, because in this query you are actually reading all the rows in from this database. There is no other option, right? So that means when you will have more places to serve from your from this database, it will take a lot of time. Hence why we will not be able to use this query. Now, whenever we face this kind of issue in SQL, what we normally end up doing it is doing is basically what we do is we do indexing on the column where we are getting a lot of queries, right? So here we could have done the same, but the thing is location is two-dimensional. So you have latitude one dimension and longitude another dimension. So even if you do indexing on latitude per se, so when you will run this query, if you will have bunch of latitudes after indexing, even then for them there will be so many longitude, so you will not gain much, and query is still going to be very slow because this is two-dimensional. The indexing will not enhance that performance. All right. So the next way we are having to basically find location is, what we can do is, and if you are reading about proximity service or Google Maps design or Uber, you might be hearing all these things, QuadTree, grid division, and S2 library from Google. So yeah, we are actually discussing all those techniques. So grid division is nothing but think of that this is your so this is actually the world map, and if you divide the world map in equal grids where this square is nothing but defining a boundary, where this corner is one lat long, this corner is another lat long, this corner is another lat long, and this corner is another lat long. So likewise you divided it in squares. Now so this is nothing but a 2D graph now, right? This is your latitude and this is your longitude. So let's suppose now you are and just to show, I'm showing it like this, where your entire almost entire Russia is in one grid, but in reality there will be so many grids even here, right? So this is just symbolic. So if you are, let's suppose you are here somewhere, this is your position, the lat long, and if this box, what you can do is, given your latitude and longitude, it is very easy, via geometry to find out in which grid you are in. So once you know that you are inside this boundary, and this grid will have some grid ID, just say that this is your grid 1, this is your grid 2, likewise you have multiple grids. Ultimately when you from given latitude longitude, when a user is sending request that I need all the restaurants surrounded by me in this circle, so what you can do is, once you found out the grids, you can do a simple SQL query that where grid ID is G1, give me all the restaurants in that grid, right? Will this work? Yes, it will. Now, what is the issue? It will work in terms of the performance of this query will be high, right? Because now grid ID is just one column. You can do indexing on it. You can do even you can do sharding, right? Now, issue with this is you cannot have same size of grid divided, because think of even in this picture, somewhere here there might be, you can say, zero places, right? Because in water there is no restaurant, right? But in somewhere in say in India, in Delhi, right, in that area there might be, in one grid there can be thousands of restaurant, right? So this is kind of very uneven division. So it is possible that some of the, if you are sharding, right, the data, then some of the shards will have a lot of data and other shards will have smaller data. And in that situation you will never be able to handle that performance, or you can say scale of the system, which leads us to the next option which we are having. Now next option is actually very interesting, and this is used in most of the professional services. We call it geohashing, right? It's very similar to the previous one. Just think of what we are doing is nothing but converting this two dimensional latitude longitude into somehow into one dimensional. Now how we are doing it? The same graph. Now think of that this is a two-dimensional uh, graph. So this is a world map. We are just saying that the y-axis is your latitude, the x-axis is your longitude. Now this, from here to here, we are saying our longitude represents a 0. Now from because we are saying that the center of the world is basically our 0 0. If we are saying it now here to here, this is, you can say, 0 for longitude. From here to here, which is basically 0 to um, yeah, from 0 to 180, this is, we are saying our longitude is 1, right? Now same for latitude. From your minus 90, or sorry, minus 180 to 0, which is this, is basically, let's call it a 0 for latitude. And from your 0 to 90, uh, let's call it a 1 for latitude, right? Like we represented it here. Now if we are calling it, and if we divide this entire world map into four grids, so this will, for lat long, this will represent as 0 0 0 for latitude, 0 for longitude. Now this one, 1 for longitude and 0 for latitude, this falls in 0 for your longitude and 1 for your latitude, and this one will be 1 for both. So this is when we are dividing the world into four equal areas. Now if you further divide any of this grid into further four parts, then what you will do is 0 1 is basically, you can say, the ID of this entire grid, right? This entire grid. Now because we divided it further, then you will append further, you can say, if this was 0 1, then what you will have is 0 1 and then 0 0 for this corner, 0 1 and then 1 0 for this corner, then 0 1 for the grid, and you can say 0 1 for this corner, and for this one is basically 0 1 for the parent grid and 1 1 for this corner. Likewise, basically now further you can divide this grid into four parts, right? So same way, what we will do is we will keep dividing the grids into uh, whichever size we want to. For example, maybe Greenland is going to have very less places, so that the entire thing we can fit into one grid in our database. We will just store it as. Whereas for India, we might divide that into several small grids. Same for US, right? We will divide it several small grids. Ultimately, you can say now for a point in India here, which is nothing but a latitude, longitude, that can be converted into a binary number. So it will be a binary number which will have that entire 010101 hash, right? So now what we did is we converted that two-dimensional latitude longitude into a simple binary number. Now how we are going to use it? So for example, let's suppose for Microsoft India Bangalore, this is their hash. the binary, right? And if we convert it into base 32 to just make this smaller, it will be something like this if we convert this base 2 to base 32. Now here I just created a table that on given of these, the lengths, that for this base 32, my first four digits are actually, you can say it will be for 20 kilometers circle, right? So a grid, you can say all the things within 20 kilometer from one center will have four, you can say, prefix substring as same, right? This is not true for everything, but for most of the parts. So let's just go ahead with it. So same for, you can say, and this is actually 5 to 20, not just 20. Same for 1 to 2 kilometer, the five prefix, five initial five characters will be same for all the things within a kilometer of 1 to 2 kilometer. In that radius, all of them will have prefix as common for up to 5 length. And for zero point 0.5 kilometer, this length is 6. So now if somebody is sending me a request then that I am standing here, that means my latitude and longitude is x comma y, then what I will do is first I will convert that x comma y into a geohash. So my geohash will come something like 9q9h something something. Then because I stored that into database like this, that my place was my place ID, then latitude, longitude, geohash, and other columns. So I will run a simple query that give me all the places, select all places where geohash like, and if I want something between 5 to 20 kilometers, then I will simply give only 4 length of substring. So wherever prefix is this, that give me all those IDs, right? If I want to further, dug deep and I want a smaller circle, then I may match, up to 5 or 6, a substring of that length as prefix into my result. So this will work in most of the scenario. Now there are some exceptions where this technique doesn't work. The exceptions are that if you are, just think of this grid. Now in this grid, if you are at the boundary here, right, and if you are looking for something, then something which is in the next grid, which might be only 0.5 kilometer to you or 1 kilometer to you, it is possible that for that address, the geohash is entirely different. Means possible that for you the in grid which is on left hand side, the geohash is 9q9h something, and the point which is right hand side of this boundary, then this is like 8l9y something like this. So it is possible that they are very near, but still not a single character in the prefix of this length is matching. And these are actually known boundary cases. So what we can do is we can write separate boundary condition catch for it, that if request is coming from this, then this is a boundary case, and for that the we need to include the neighbor grid as well, right? So we can have another table into our database which will have, you can say, neighbor grids also, that for my G1 the neighbor are basically G2 and you can say G4. So when we are searching something at the boundary, we might consider G2 as well and G4 as well, right? So we can handle the boundary case like that. All right, let's talk about the next option we are having. So next is QuadTree, and in proximity, QuadTree is a very famous data structure or technique, you can say, we use so that we can find out uh, all surrounded objects from a given point. Now, how this works? So this is very similar to what we did earlier, but so first is for a given location, just divide it into further small areas like this. So if let's suppose this is 100 kilometer, just divide it into 25, 25, 25, 25, four different areas. So this 100 will become the root node like this, and then 25, 25, 25, 25 kilometers are the child nodes. When a given when user is sending special points, latitude and longitude, so you will see that user falls into this parent node, yes. Then this is 100 kilometer, and you might be looking for all the objects within 10 kilometers. Then you will see that next, whether this point is in this child node or this child node or this or this. So once you find out the child node, you will go in that um, child node, and you will further do the same thing. If point is here, then this might further divide it into 10, 10, 5, 5, right? So then, if you want to go further drill down, you will basically find out the next child node where that point lies in. The benefit of this is basically finding is going to be very fast, because it is a tree-like structure, and you can go to any level in logarithm of that, the logarithm of number of nodes, uh, just by the logic of how we do binary search in a tree. Now, thing to notice here is QuadTree is not something which runs on database server. This is an in-memory data structure, which means that your location, you can say your location finding service have to have the entire quadtree in memory, right? Or you can think of that behind this there are servers, and there will be obviously load balancer in between. There will be services, and all these services are having a copy of the quadtree. So that entire quadtree is here. That means that entire world, or maybe we can do it like for America, there are these five servers, right? For India, there are these three servers. So all the node related to India locations, that entire quadtree is here. So for 2000 kilometers of Indian land, it will be there will be two copies in these two servers. So, like any in memory computation, whenever these servers are going up, they will fetch the data from database. They will build the entire, tree, and then they will say, I'm ready to serve any service. And whenever you are hitting, request will go here. Recursively, it will find out the location, all the location, and it will return the response. So, benefit we know, because it is in memory, finding will be very, very fast. The complex part is, if you have to modify these places or add new places very frequently, then quadtree will be very difficult to manage. Think of multiple threads are trying to update the quadtree. It will be very difficult, and an extra overhead which normally people do not include in their design. So QuadTree, for this particular proximity service, can work, because here we are adding places rarely, the users are adding. But in services like Uber, where we have to find out the real time places which are like moving, a cab is moving, so you have to find out within 10 kilometers. Their QuadTree, maintaining QuadTree will be very difficult and expensive also. So next option we are having is a service which is provided via Google, and that called as Google S2 library. This is an open source library, and it is very difficult, to explain all the features and how it works, rather than the feature how it works uh, here in this video. But what we can focus on is what all features it is providing for us to use, right? So this also works on similar, you can say, idea of dividing a bigger cell into smaller cells, and the boundary is defined via some points, right? But the thing it is forcing is that user means we are using it for proximity service. We can define the geofencing, that this is my given fence, and I will query everything within this, right? Then user can query to give me all the places in this given boundary or fencing. And then the most important part is you can define your fencing or boundary in any shape, like the example I gave here. So it need not to be a square or rectangle. It can be, you can say, almost any shape. But obviously the points you are defining have to be limited, right? So you cannot define a sphere, for example. But then there will be too many points. The fencing will be very complex to handle. So it has to be something like this. Okay, so yeah, these were the options we had, and as per our requirement, we can choose most of the services because they don't want to handle the complexity themselves, and they want to reuse what Google already created. So most of the uh, you can say enterprise level applications used S2 library for this purpose, and they in fact use the managed one where they are paying to Google to handle all the complexity via Google. So these were our options: S2, then QuadTree. Uh, Basically, we had geohashing, which is, you can say, the most important for us to understand while when we are in an high level design interview. And then a grid division was the basic one, and two-dimensional search is just to explain you that what is the complexity we are having when we are working on locations, latitude and longitude, right? Now let's just expand our design, right? So design is very simple. The main thing was here to discuss about these options we are having. So we are just expanding our previous high level design which we created. Now for admin, nothing will change. We will have location update service, right? And behind which we will have a primary database in which you are dumping your data. Then for end user, we had location finder service. So just to basically give you an idea, it will because we are expecting that our read is going to be uh, more demanding, right, rather than write. So we will obviously need so many servers behind this query. So we will have global load balancer, or in fact we can have a DNS mapping service, right? Such as, you can say, a simple um, gateway, right, which is just mapping. If you are coming from India, then you will go to this server. If you're coming from US, then you will go to this server, kind of a thing, right? Then behind that there will always be in front of service there will always be, you can say, a ingress controller. In case of AKS, if you are working on, you should be aware of it, or you can say it will act as a regional load balancer. So now if you called East US or Central India, then in Central India also there might be hundred of the pods where service is running. So this load balancer take cares of how to divide the load between those hundred of pods when a lot of requests are coming. So likewise, there will be different regional load balancers or ingress controllers, and behind which there will be this location finding service. Now location finding service will, you can say, ultimately, because our read is heavy, so we can have a cache to serve fast. So hence why we will use a redis, distributed cache, which will be a redis cluster. And for fast serving, there will always be a cache which is near to, the same region. So like for east AKS cluster, there will always be a east replica of the cache. And how we are going to build this cache is from our replica databases, right? So from replica DB, we will, whenever there is a miss from uh, for server in this cache, they will find it from the replica DB which is near to them, and then they will update the cache, right? We can build the cache separately also. It depends on what kind of we need aggressive loading or passive loading. So that I will leave for you to decide in this design, because that was not the real focus. That anyway we will discuss in multiple design. Real focus was in proximity, how many options we are having when we are talking about searching something within a circle, right? And adding dynamically adding places. So here I only talked about static add, means very it is not like you are adding in every 5 second like in case of Uber. Here I was only talking about when you're adding restaurants, which is like once in a month, right? So yeah, so this was it about this design. This is what I wanted to discuss. Let's meet for the next design. Thank you very much. Take care. Bye bye.